Oh, hello. Greetings, Earthlings. Thank you so much for watching. I am going to be giving us a quick tutorial about how to analyze and detect fluorescent particles using the image processing software called ImageJ. This is super intro, but I remember when I had to learn it, and A, it was cool, and B, it was confusing. So let's get started. Okie dokie. So, hold up. Let's go ahead. I just got to find some particle photos, you know. Oh, that's on a microscope. Okay, so what I'm looking for right now is just like some cute little particle photos. Ooh, look at how cute these are. Okay, so if we were looking at this on the benchtop microscope, if we were looking at this thing here, that would be green. Oh, I can't even describe it. I think it's one of the most gorgeous things ever. It looks like sparkling stars in the galaxy. Like, who needs to visit a planetarium when you can visit the microscope where you are all the time? Okay. So we're going to drag and drop. Okay, so ImageJ. I downloaded it previously. If you haven't got it, download. It's very easy. I can put the link down here in this video. I did used to use this on a Windows computer, and I have to say it worked a little bit better for all functions. There's a couple plugins that I haven't been able to get work on this Mac. However, for image processing, the basic stuff, it's perfection. So you drag your photo over here, got it highlighted. Now what I'm trying to do is isolate all of these particles. So first thing I'm going to do 8-bit. Then we're going to do some thresholding. Now this is going to turn into a binary image. So it was pretty black and white originally, but we need to make it completely black or white in order to use this analyze particles function. And now the trick here is you don't want to lose info, but you don't want it to look like this, which is false noise. So I remember that there was a couple here, one down there. So it's usually around 99.9. Okay, now let's compare it to the stock image. Okay, this is too much. Let's go back. On the smartphone images, it's a little easier to do this just because it's a lot more obvious. We have color on the smartphone images. Maybe one way it's better. I don't know, I'm biased. Okay, look, 1, 2, 3, 4. I love this. Okay, so once we're satisfied, apply. Good. Now the final step that we do is we come over here to analyze particles. Now these functions here, the size, this is specifying what size of clumps you want to have. So if I say 0, then if there are any little 0, 1 size pixels in here, it's going to include those. And if I give a limit, say example 20, it won't include these big ones. Now I do all of my analysis post this. I just copy the results and put them into Excel, and that's where I do my size thresholding based on this value. So I just let it give me everything. Circularity, this is where you define like how much of a circle it has to be. I also just let this be everything because all of my particles are typically satisfactory. However, if you had a different shape you were dealing with, then maybe you would have to experiment with that there. And then I always click show masks so we can see what came through. Display results, clear results. Okay. So this is the mask. It looks exactly the same because we were already black and white. So that looks great. Summarize. Okay, that was a total area. Oh, never mind. Oh, I think I should I binarize this? Okay, I needed a white background. Let's try this again. Bingo, baby. Okay, here we go. These are our results. So this was the one from last time. Let's delete that. Okay, so this is from all of our particles. So we've got 5 particles found. That kind of corresponds 1, 2, 3, 4. And this one here might be a 5. Okay. Yeah, look, I bet this big one is 669. Unfortunately, it doesn't show you which one's which would be pretty awesome, but I think it's good. So then all you can do is just Control A, copy, and paste it into whatever Excel spreadsheet you're working from, or if you can get the data just from this, then you're set to go. And that is how we find fluorescent particles from microscope images without having to individually count every single one, or without having to like guess the size. It's fine if you just have a couple particles like in this photo, but once you start having a large concentration of fluorescent particles, love this analyze particles function. It's amazing. And it could also work for cell counting, so many other applications as well. If you take a picture of the actual sky, I bet that would work too. Ooh, let's do that. Okay, cool. Let me know if you have any questions. Thank you for watching.